Good morning, everybody who's here. New week. Very exciting. Welcome, Joey. I was wondering if anybody showed up. We got 6 people. It's getting later in the semester. Harder to get up, I'm sure. Harder to go to class. But the sun is shining more. It's shining earlier. It's very exciting. Last week of programming? No. We have... This week is branching statements. Next week is looping. And then we have a tiny bit of plotting. And then our midterm. And then we will transition to linear algebra. So almost there, JR. Not quite. JR Conrad 20. Do you want to be done with programming? I mean, I like the programming stuff better than the linear algebra. The linear algebra's fine. No. We'll go through chapter 9 for Zybooks in programming. Anything past chapter 9 is kind of, I don't know, standard math textbook. It's not very exciting. We don't make you read that. Morning Zanzib, morning brain fog. Hello, Tidy. Tidy 400. There we go. Oh, that's good. That's good. Programming is different. Morning, Matt. Programming, I don't know. I really like programming. It's logic. I'm a very logical person. Not that I can't understand highly emotional reactions, considering there's a logic behind that as well. But I'm a very logical person. Like, things have a space, things are very organized, and programming just kind of fits in that personality corner of mine. Yes. I've had some positive responses from students. I'm very excited that some of you guys have really enjoyed the class. I'm trying to make it as applicable, as focused as possible. I'm trying to focus a little bit more on showing examples and teaching from example. Yeah, I mean, honestly, anything that you guys have to suggest, I would really appreciate. And so I think mid-semester evaluations are going on right now. So JR, we will do that the last week. That's when we get to plotting. And we're going to get to, there's not going to be an extensive amount of plotting we're going to do, but you can always explore on your own moving forward. But we will get to plotting at the end of our programming session. But anyway, any suggestions you guys have for improvements, I really appreciate your guys' feedback. I mean, I learned programming for the first time back in, I think, 2009, 2010, which wasn't that long ago, but it's been a while since I was a first-time learner of programming. So any feedback that you guys have to understand the material more clearly, or to even explain the material in a different way, I really appreciate that. I don't know, I like your guys' perspective. Don't know what that means. Okay, it's 9:10. Let's go ahead and begin. So I looked at the quizzes, responses, which there weren't as many people who filled it out. And that's fine. Once again, there's no defined due date for those. But I looked at people's responses, people's questions, stuff that they had issues with, and it doesn't seem to be like there's an extensive amount, which is good. Quite a few people still mentioned struggling with arrays, and that's understandable. Go back, review the homework for the homework solution for homework 3. I'll post homework 4 solution today. I need to make a note to do that. Go back, look at those solutions. Hopefully they make sense. Come to office hours. I can always re-explain things in office hours. Talk to a friend. When I first learned programming, I had a friend, my husband actually, who, not my husband, he sat down and was like explaining things to me, and just the way he explained it, stepping through things, really helped. So find a friend, come to office hours, but don't feel bad if you're still struggling with arrays. Like, that's real. It's not quite the same as it is in other languages, so it is different. So just go get help. I'm not gonna go over too much more in class with arrays. We'll just keep using them. Some of you guys mentioned load and save, also understandable. I'm going to review some of that as we go through our next material, go through material today. Also, disp and fprintf. Once again, those are also a challenge. I will go through some of that as well as we go through our next set of material. So hopefully I hit most of the points that you guys talked about, but I don't have anything specific that I wanted to review based off of your guys' responses. Homework 4 solution. Okay, so let's go ahead and get into our new material. So this week we are going over conditional statements using relational and logical and equality operators. And we will practice a lot of that throughout this entire material. I'm not going to focus specifically on using those operators, but we have quite a few. We have greater than, less than, greater than or equal to, less than or equal to, equal to, equal to, equal to. So note the double equal sign versus the single equal sign. And then not equal to. MATLAB's not is the little tilde. In other languages, it's the exclamation point, but in MATLAB, it's the tilde. I might type it incorrectly a couple of times because I teach C/C++ in fall. So if I screw it up, I'll figure it out, or you can tell me. We also have the and, single, double. I'll talk about when you would use one or the other. Really, the key point is use this one with arrays, use this one with scalars. Same thing with the bar, double bar, single bar for or. If you do not know where the bar is on your keyboard, it is the shift / right underneath backspace. I'm not gonna lie, I did not realize where that was for a long time. And then we have just the single not and the XOR, which is technically a function. Okay, so we've got relational operators, equality operators, and these are our logical operators. So I talked in the videos about what a logical is. It's a true or a false, where true is typically the number 1, false is typically the number 0. Those are our answers. So we're starting to ask questions. And if you notice in question 3 of the quiz, I phrased the questions as a bunch of questions. Like, is the number 5 greater than 10? And that's essentially what we're starting to ask. We're starting to make decisions based on values. So if the value inside of our array is greater than 0, do this. If it's not greater than 0, then do this. So we're starting to make decisions. We're starting to do certain things with certain numbers and other things with other numbers. So B.I. Duncan, we'll say that's what it is. Why true is negative 12? So it turns out true is anything that's not 0. So false is 0 and true is not 0. Yeah, that's a little syntax. Tilde 0, so not 0. Which means that negative 12 is true, 0.001 is true, 15 is true, negative 1,000 is true. Everything that's not exactly 0 is going to be considered true. That's just how someone decided true and false would be indicated in a computer. Okay, so this is our wheelhouse for right now. So I'm going to focus on some examples, and these examples, these first two examples are going to focus on essentially how we can use these operators in order to just get a bunch of information. Before we do that, though, no, I'll do that later. I also have one other example that just also demonstrates why this stuff is useful. Okay, so let's look at this first example. The recorded daily temperature in New York City and in Denver during the month of January 2014, arbitrary month, is given by the data file, this one. The first column is the day of the month, the second column is New York City temperatures, and the third column is Denver. So if I open up the file, it looks like this. So here's the day of the month, here's the temperature in New York, and here's the temperature in Denver. So it's important that we know that, because when I load this data into my program, using the load function, I need to know what all of those columns mean. So here's a little bit of review on load. In order to use load, you type load. It's a function. Open close parentheses. And then you just type in the name of the file, nycdenjan.txt. Okay. Note this file needs to exist in my current folder, and that's it. That is the minimum amount you need for load. If I press run, in my workspace now, we will see a variable that's the same name as my function, or has the same name as my file that contains my data. So I can change this, say I don't want my variable to be the same as my file, I want it to be temps. I would just say temps equals. So now when I run, now temps stores my results. That is the minimum amount you need. You also don't necessarily need the parentheses. You could just say load nycdenjan.txt. You could also just do this, but you can't rename that variable. So there we go. That's a little review on load. Okay, and then I'm going to split this file into 3 different variables. So day is going to be temps all rows column 1. New York City is going to be temps all rows column 2, and then Denver is going to be temps all rows column 3. I'm just spreading it out so that it's in 3 different variables, which I don't have to do. I'm just doing that so that I just have clear variable names that identify what each column consists of. Okay, so now I'm going to start determining some information about these, the temperatures. So here's the first thing. Determine the number of days. So the number of days, the temperature was above the average. So essentially I'm saying if the temp was above the average, okay, for both cities. So first thing I need to do is I need to find the average. So NYC average equals, I'm going to use the mean, nope, help mean, yes, okay. I know in Excel it's the AVG function. In MATLAB to find the average, we use the mean function. So I'm going to say mean NYC. And then Denver average equals mean Denver. And those are probably going to result in, well, one section. So those will result in decimal values, which is fine. I can round them if I wanted to. Don't necessarily want to right now. But I have my averages. Now I can just go ahead and say NYC greater than NYC average. NYC is an array. Here's NYC. It's an array. NYC average is a scalar. So we can use these operators on both scalars and arrays. So we got 3 different combinations. We either have a scalar and a scalar, which produces a scalar and array, which produces an array, and then an array and array, which produces an array. So it works just like our element by element operations. These are considered element by element operators. So here I have an array, here I have a scalar. So when I compare these two, I'm going to compare this scalar to every single value inside of my array. So here's my result. I get what's called a logical array, which means it's full of ones and zeros. It's full of trues and falses. Trues and falses. Yep, that makes sense. Where it's taking this scalar and comparing it to every single value. So it's saying that this first number is not greater than the average. This second number is not greater than the average. Either is this one, this one. These next two numbers are, this one isn't, no, no, yes, 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 or true, 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 true. You can think about true and false as yes and no as well. But it compares them so that if I put these two arrays next to each other, so NYC next to ants, I can go through and say 33 is not greater than the average. 18 is not greater than the average. 29 is not greater than the average. 40 is, 55 is, 19 isn't, 22 isn't, 32 isn't, 37, all the way down to this one. Those are all greater than average, etc. Okay, so that is finding the which temperatures are greater than the average. I want to figure out the number of these greater than the average. So notice this logical array is full of ones and zeros. If I just sum this entire array, it's going to sum up all the ones. So what I'm going to do is I'm just going to say, so 1. I'm just going to sum it. So this gives me my logical array. And then if I just sum all of those values, it just counts how many of those are true. And that's what the sum function does in this instance. It just counts how many of those are true. It just sums up all the ones. So 1, 1. So it's a nice trick to figure out how many exist, given the fact that I'm trying to find the number. So it matches what I'm trying to find. Okay, so let me rename this so it's a little bit better. NYC above average. Or NYC above. Now I'm going to do the same thing with Denver. Den above. First, I'm going to say Denver greater than Denver average. Once again, same thing. Here I have an array. Here I have a scalar. So it's just going through and checking where each of those temperatures in Denver. So Den next to going through all of my temperatures in my Denver temperatures and checking to see how many of them are greater than the average temperature for that city. So 39 is not greater than the average, 48 is, 61 is, 39 is not, neither is 14, 37, 43, 38, 46 is, etc. So one by one. Once again, to figure out the number, I'm just going to sum them. So there's my first two. Or my first one. Oops, this is supposed to say below. So next I want to figure out how many days were below the average. So it's the same process, but now I'm going to use less than. I could say less than or equals to. It doesn't matter. However, my average is a decimal point value, so I don't technically need to. I'm never going to run into that instance, but it's still just good practice to count for any situation of where it might even be equals to. So I'll run it. So 18 temperatures are above the average for Denver, 13 are below, 15 are above, and 16 are below for New York City. Okay, first two done. Now I want to determine the number of days the temperature in New York City was above the average of the temperature in Denver, and the number of days in Denver, the average was above New York City. So we just change our comparison value. So instead of comparing New York to New York, I would just compare New York to Denver or Denver to New York. I'm not going to write the code in terms of time. Same thing for below. Let's get to this one. 7, 8, 9, 10. So it says determine the number of days the temperature in New York City was between the two averages. So between, which means let's see, look at my temperatures. My New York average is 35 and my Denver average is 44. So my New York City average and Denver. So I want to figure out how many are between there. So that means I want to figure out how many are above 35 and below 44. In math, we would typically just write this expression like this, where we just say x greater than 35, greater or less than 44. We would write it like this. In programming, we can't do that. In programming, we can't do that because we have order of operations. So I had a huge list in the notes of the order of operations. In general, the order of operations follow math first, and then it's going to do all of your relational operators, and then equality operators, and then logical operators. Okay? So that's the general order. Math first, and then it does these comparisons, less than, equal to, greater than, equal to, and it does your equal to, and then it does your logicals, the ands and the ors. So what we need to do in programming is we always need to break up our expressions like this into smaller pieces. Essentially compare one set of comparisons, one set of comparison, one set of comparison, and then we combine them with our logicals. So here I have 35 less than x less than 44. So I'm going to break that up into two pieces. I'm going to say x greater than 35, and then x less than 44. So there's my two pieces. It doesn't matter which way I write them. I could also say like this. So I keep my x in the middle, but now I've just broken it up into two separate pieces. So whenever you are writing your logical or your conditional expressions, you're comparing things, you need to have individual comparisons that you're going to combine now with our ands and ors. So here's my first one. Here's my second one. If you have a range that you have overlap, so x greater than 35 looks like this, and x less than 44 looks like this. I'm looking at this overlap. You would combine them with and. So I'm checking to see if x is greater than 35 and if x is less than 44. It helps to talk out loud to figure out what the English language is or what the language is. And indicates you should probably use the and, or indicates you should use the or. So now it's checking to see if x is greater than 35, if that's true, and if x is less than 44, if that's true. So look at your truth table. And is going to be true. This whole thing is going to be true if both of these are true. Otherwise, it's false. Or is going to be true if one of them is true. But look at your truth table. Follow that logic. It's written in the notes. So I'm trying to figure out the number of days that New York City temp was between these two, greater than New York City, less than Denver. I can't write it like I do in math. I need to break it up into two individual expressions, individual comparisons, and then combined with a logical, with an and an or an or. In this instance, I'm using and because those two ranges overlap. So Aurora, that's a really good question. Use a single ampersand or a single bar when you are comparing arrays. So here, my x in this instance would be an array, so I'm going to use the single. If you're comparing scalars, you would use the double. And MATLAB will yell at you. We'll see that in a minute. I'll show you what it looks like for both. Okay, so here we go. So I want to say 35 less than my New York City temperature and New York City less than 44. Okay. I don't need these parentheses, but sometimes it's helpful to clarify what you're comparing, what you're combining. Order of operations will automatically do these less than, greater than first before it does the and. So you don't need them, but like I said, combining. It's just clearer sometimes when you have the parentheses. Okay, let me just store this in a variable. Okay, so let me demonstrate this. So here is NYC greater than 35. Here's NYC less than 44. So if I put these two next to each other, and I and them, it's looking for all the locations where they're both ones. So and looks for where there's both ones, both true. So here's false, 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 false. Here I have 1, 1, not 2 though. So this would still be false. Here's where it's going to be true. False, 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 true, 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 false, true, false, false, true, etc. So this whole expression is going to be true when both of them are true. So let's go ahead and put all of those together. So here's the first one, here's the second one, here's both. Hold on. That's not right. Why are you failing me? Oh, that's why. There we go. Okay. Sorry. I had something incorrect. Once again, that's real life debugging, not realizing why isn't this behaving the way that I expect it to. Going back, looking at what you typed, where is some logic, either there's a logical breakdown or some syntax breakdown. So here I had a syntax. I meant to do greater than, or less than instead of greater than. Okay, so when does the plus plus function exist within MATLAB? So there is no plus plus in MATLAB, which is very, very sad. But there's no plus plus, sorry. Okay, so here's my original array of New York City values. Here is where they are greater than 35. Here's where they are less than 44. Here's when they are both. So notice they are both a 1 when they are both 1 here. So here's true, here it's true, here it's true, here it's true, here it's true. And here it's true. Okay, so and looks at where these both are true. So where's the overlap between those two ranges? Okay, if I had used double ampersand, you would get an error in MATLAB. It would tell you operands, double operands must be convertible to logical scalar values. It just means that you need to, or you can only use these with scalars, not with arrays. So here we go. So here's my result. This is where they are both greater than 35 and less than 44. And once again, if I want to know the number of that, I just do sum. I can just sum all of that. So here, there are 6 locations or 6 times where the New York City temperature is between New York City and Denver. And I can do the same thing with my Denver temperatures. My variable names are becoming less creative. Okay, so that's if you're looking for between a range. If you are looking for if a number is between 2 numbers. Let's say we are looking for if a number was above or below the 2 averages. So determine number of days the temperature in New York City was above the average and below the average. So we're checking to see once again, my two temperatures. If I have a temperature below this one, so in this range, or above this one, in this range. So in math, this is a little more typical to what we would see in math, where we would have to do two comparisons. So if it's less than 35 or greater than 44, once again, it helps to talk this language out. No, you cannot use no, you have to use the comparison operators. You can't use sure, yes, you can. You can use the LT function or the GT function. Those will do the same thing if you want to. If that makes a little more sense to you, sure, go ahead. Those exist. No one's ever asked that before. I didn't even know that's what those were called. But anyway, so if it's outside of a range, so if there's no overlap, we want to combine the two with an OR. So we have x less than 35 or x greater than 44. So if there's no overlap, we want to use OR. If there is overlap, use AND. No overlap, use OR. Once again, talk it out. Notice when you may not have noticed, but I noticed because I was looking for it. When I talked this out, when I wrote out this range here, where x is less than 35 or x is greater than 44, I used the word OR. OR indicates I should probably use an OR. So once again, figure out where x or NYC is less or greater than greater than 35 or less than 35, or NYC is less than 44. I mix my expressions up all the time, greater than, less than. It doesn't help for me for some obscure reason to speak it out loud because I'll still just mess up the notation, which is why it's really important that you guys develop your debugging skills, where I'm looking for, so here's NYC less than 35. So I'm looking for all of the values that are less than 35. So I can pull up my NYC array. So NYC, next NYC less than 35. And I can just double check, okay, yes, this value is less than 35. True, 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 false, false, true, true, true. And I can check to see that my logic, what is actually happening, matches in my brain what I expect. Same thing with NYC less than 44. I should be NYC greater than 44. Once again, this idea of what are you expecting? So NYC greater than 44, I can combine that. So here in the first column is my NYC temperature, second column where NYC is less than 35, NYC greater than 44. So once again, checking. So less than 35, yes. Greater than 44, not greater than 44. So I can see and compare what is my program doing and what do I expect based off of the logic in my brain I expect to happen. So here's my first question. Is the New York City temperature less than 35? Second question, is the New York temperature greater than 44? I combine those with an OR. An OR is going to be true if one of these is true. So it's looking to see where there is just at least one. So true, 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 false, true, 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 false, true, 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 false, true, and then it keeps going. I did something on accident. So now if I combine my questions, here's my third column, combining them. So notice it's a 1 wherever there's at least 1 in these two middle columns. So here there's 0, here there's 0, here there's 0, etc. So there are a lot more times where the number of temperatures in New York City is outside of that range versus inside of those averages, which is fine. I mean, it's just a basic example. And I can repeat the same thing with my Denver temperatures. There we go. Found all of the things I was looking for. So that's just a basic example of how we might use some of these relational operators. Like JR said, you can use the LT and GT functions. They do the exact same thing. Although a lot of times it's clearer to do it like this because you can easily see the expression. And then I can print out my results as well. So however you want to do it. So display the average or the city, the average, the above the average, below the average, between the averages, and outside the averages. Starting with that, and then display your results. So display NYC, place next to, nope, I can't do that. I'd have to use fprintf. Fprintf. The word NYC, place next to the average, 0.2f, place next to the number below or the number above, place next to the number below, place next to the number between, place next to the number outside. So this first one, the average is NYC, average. The second one is NYC above. Third one is NYC below, and then A and C. Repeat for Denver. Denver average, Denver above, Denver below, and then B and D. Once again, more clever variable names. But there we go. There's my results. It's not spaced out the way I want it to, so I just space it manually. Average should be over a couple more, I don't know. Start there. A little bit better. Average a little bit more. There are more sophisticated ways to do that, but just this works. It's just a lot of trial and error. Yay! Oh no, dang it. There we go. There's my table. It's not a beautiful table. It doesn't use arrays, but I'm just printing out all of my results. Okay, that's my first example. Hopefully that helps clarify some stuff. Let's get to another example that goes over this stuff as well. We've got about... When you use the OR function, did that find the values in between the two? So when I use the OR function, it found them outside of that range. So when I use AND, so AND is for between two numbers, or is outside of two numbers. And once again, just follow the language, like speak it physically out loud. So if or x is greater than 10 and less than 20. I use the word and, greater than 10 and less than 20. Or you can say x greater than 10 or x less than 5. Hopefully I wrote those right. Once again, using the word or. It helps combine things. It helps you talk through what to combine. And a lot of this, sometimes it's just trial and error. Once again, I always type things incorrectly, so you need to follow the logic of what do you expect in your brain to happen. You need to match that to what you expect to happen in your program. Okay, let's do another basic example. Nope. So let's say a list of final scores for this course for the fall 2018 is given in a file. So the file EAS 230 F18 scores, they're random, arbitrary, not real scores. The first column is a simulated person number. The second column is the grade out of 100. And once again, we need to know a little bit about how the data is stored in order to load it into our program. So I'm going to load it, data equals load, name of my file, EAS230 F18 18_scores. Ta-da! There we go. The data will be loaded into my file. I can break it up, so the person number, so the ID, would be data, all rows, column 1, and then the scores is data, all rows, column 2. So given these scores, I want to figure out how many A's there are, how many B's, how many C's, D's, and F's, using these ranges. So when A is considered greater than or equal to the average plus 1/3 times the standard deviation. This is how you would calculate a standard curve, which we do not do in this class. It's just an example. But this is how you would calculate a standard curve. So first things first, the average is going to be the mean of my scores. And then my standard deviation is STD of my scores, right? Yes, the STD function, standard deviation. I'm gonna round them. Yeah, round. I'm gonna round them, so I'm working with whole numbers. So here the average is 79 and the standard deviation would be 14. So if I want to figure out how many A's there are, I would say scores. So my A's would be scores greater than or equal to the average plus 1.3 times the standard deviation. So once again, it does math first. So it's going to calculate this, which is 97.2. So it's going to see how many of these scores are greater than 97.2. There are like 200 scores, so I'm not going to show that. But if I'm looking for the number, once again, I just sum it. So according to this, there are 9 A's. Once again, not the instance in this class. It's just a very brief example with randomly created numbers. Now I want to see where the B's are. Notice the way that this expression, Notice the way that this expression is written. I have S in the middle here, my score's in the middle. I am combining these two ranges, or I'm checking to see where the overlap of these two ranges is. So first I'm going to ask this question. I'm going to figure out how many scores are greater than average plus 1/2 of my standard deviation. And then I'm going to ask this second question. How many scores are less than the average plus 1/3 of my standard deviation? And then combine those with and. Okay, so first figure out where the average plus 0.5 times my standard deviation greater than or equal to my scores. And then also ask where my scores are less than my average plus 1/3 my standard deviation. So first question here, second question here, combine that overlap with and. And then sum that to figure out the total number. Okay, sum is just to figure out the number. If I highlighted this, it would give me an entire array full of true and false. True where the answer is true, false where the answer is false. If I don't do that, B, there's 80 B's, according to this scale. Okay, and then I would just keep going. C's, same thing. I'm going to ask this question first, figure out where my scores are greater than my average minus 1/2 my standard deviation, and then figure out where my scores are less than my average plus 1/2 my standard deviation, and then combine those two with and, because I'm looking for that overlap. I'm going to copy and paste here just for easy things to do. D's, same idea. I have my two questions. But now it's less than 1.3, my standard deviation. or greater than 1.3 my standard deviation and minus 1/2 of my standard deviation. And then with F's, it's just any score that is less than my average minus 1.3 times my standard deviation. Okay. So I've got all my calculations. Let me CLC and clear my workspace, run my code. So I have 9 A's, 80 B's, 83 C's, 32 D's, and 21 F's. Once again, not how it typically pans out. It's just an example. If I want to print out my results, I can just print them out. So let's say fprintf. I want to print out the A students. I want to print out the number. Here we go. So here it prints out the number. There's 9. Let's say I also want to figure out how many students or which students are those 9. I can also print out their IDs. So fprintf tab students equals, and let's just pause here for a minute. So I have A. A is the sum of all the scores. However, if I just had the scores, I would have a really big logical array that looks like this. So once again, there's 225 IDs in here, fake IDs, but IDs. And I have a true here, a true here, a true here, a true here, here, and here. One there. There we go. There's 9 of them total. We can do, if we want to figure out which of my locations correspond to those trues, I can do something called logical indexing, where my scores look like this. Big long array. And if I have a logical array that's of the same size, full of trues and falses, I can do logical indexing, where I can say scores of ants. Oops. Dang it. That's what happens when you don't store things in variables. I can say scores. So now, let me just redo this. Scores and A. So now A contains my logical array. If I did scores A, what it's going to do is it's going to note A is a logical array of the same size as scores. What it's going to do is it's going to grab all of the locations where A is equal to true and delete all of the locations where it's equal to false. So if I go to the top of my array, it's going to delete this one. Delete it, delete it, delete it, delete it, delete it, delete it. Delete all of them until we get to this one. It's going to keep this one. It's going to keep this one. Delete all of these. It's going to keep this one. Delete all of these. Keep this one. Delete all of these. Keep this one. Delete all of these. Keep this one. Delete, 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 delete. Keep. Delete, 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 delete. Keep. Delete. And keep. So now it only keeps all of the locations where it's true. So all the locations where it is equal to 1. Same thing with B's. Let me just take out all my sums. If I wanted to figure out who all the B's were, I would just say scores B. So now here are all the scores that are equal to B. If I want to get the IDs, though, I can do the same thing with ID. So ID A. So here are my 9 IDs that correspond to those trues. Where if I did ID scores A, B, C, D, F. There we go. Whoop. So here are all my arrays. Here's my IDs, here's my scores, here if it's an A, a B, a C, a D, or an E. So this one here corresponds to a C. This one here corresponds to an F. This one here corresponds to a B, a D, C, etc. So if I did all the way down, I should use smaller values, ID B, it gives me all of the IDs where it's equal to B. So it deletes this one, deletes this one, deletes this one, it keeps this one, deletes it, keeps it, deletes it, keeps it, keeps it, deletes it for the B's. So that's called logical indexing. So if I want to print out all of my students that correspond to my A's, here's a nifty trick you might want to do for your homework. There you go. I can just do %D space, close parenthesis, and then you list out the array, the ID of all the A's. What this is going to do is this is going to print out your entire array, just putting a space between. So here we go. So I print out A students, there are 9 of them, and these are my students. Where it prints out the word students equals from here, and then it prints out the first number, space, second number, space, third number, space, fourth number, fifth number, sixth number, seventh number, eighth number, ninth number. Where IDA grabs out all of the A's. Okay? I don't think I explained that very well. Let's go over one more time. Printing on a new line. If I wanted to print all of the B's, F print F, B students. F print F, D number. So right now, B looks like this. It's just a big, long logical array full of ones and zeros. 1 wherever it's in this range, greater than average or plus 1/2 standard deviation, less than average plus 1.3 of the standard deviation. So true, false, false. If I sum all of that, I get the total number. Essentially just adds all those ones together and I get the number of B's. So the number of B's is 80. If I want to extract all of those grades, if I want to figure out which are all of the grades that are the B's, I can just say scores B, where it's going to delete everywhere that this B array is false. It just deletes all the false values and keeps all the true values. So if I want to print out all the IDs, I just say IDs of B. So now here are all the IDs of all of these students who have B's. Once again, not real. These aren't obviously real student IDs, but example. So if I want to print those out, it would look like this. I can say %D space, and then I don't put a new line. I just say space, and ID B, followed by a new line. So ID B is all of these IDs. It just prints them out, spacing them versus stacking them. Okay, someone mentioned in the quiz when to use single quotes versus double quotes. I am going to demonstrate single quotes. To be honest, though, it's not going to make a difference using fprintf and display. It will not make a difference for fprintf display input. Single quotes, double quotes, it means the same thing. When we get to comparing arrays, comparing strings, then I will show you where it might make a difference. But for your purposes, just stick with one. Single quotes, it's fine. Double quotes, it's fine. It doesn't make a difference. Okay. Oh, I want to show you guys one more example. So I wanted to show you this example. I'm not going to step through it necessarily. Let me go ahead and run it. And this is what it produces. So flower is this original image. It's usually in color, but it's easier working with black and white. But an image is technically just an array. An image is just an array. An image is just an array full of numbers, where each number corresponds to what your pixel value is. It corresponds to a color. So for this image, 0 corresponds to black, and 255 corresponds to white. So what I did in this image is I did what's called thresholding, where I checked to see how many values are greater than a threshold, like 1/2 of the max, 2/5 of the max. In this one, it was 1/2 of the max. And then what I did is I took that resulting logical array, where that told me where all of those values are located, and I multiplied them. I multiplied these two together. So what it did is it extracted all of the colors in this image that were greater than 1/3 of the max. So if we look at the code, it's really simple. It's 2 lines, really. 2 lines of code. This first line reads in the image from a JPEG. So use the imRead function, converts it to a grayscale versus RGB. And then here's where my threshold is. I just found, okay, so find the max of the image using the max function, multiplied it by 1/2. This is a scalar value. This is a scalar number. It's 123.5. And then I said image greater than max. So the same thing I did to find the scores. Image is a big array. Image is, where is it? It's a 640 by 960 array. So my result, mask, is a logical array of the same size that is true wherever my image is greater than that number and false wherever it's less than that number. So now I took my mask full of 1s and 0s, multiplied it by my original image in order to get these original values back. This is just some very, very basic image processing that we can do. Very basic. In most other languages, this would be lots of lines of code. This would be using nested loops to find the max, nested loops to do the comparison, nested loops to do the multiplication. Whereas in MATLAB, it allows us to do this basic processing using 2 lines of code. So I just wanted to give you guys like a real tangible example that I think is really cool. I used a flower image, but you can really use any image you want. Obviously, it gets a little more complicated when you have red, green, and blue pixels, but here's just a basic grayscale example of how we can actually apply this in real life. Okay, I am over. Any final questions? So Joey asked, what's the difference on using fprintf and display? To be honest, there's not that much of a difference. Use whichever one you're most comfortable with. I could not do this with display because display automatically has a \n, whereas you notice the students equals is printed, and then this next line here follows right after. So I couldn't technically do this with the display function, but for the most part, they're mostly interchangeable. fprintf just gives you more explicit control over everything. There is slightly different syntax, the way you combine things, but they can do mostly the same things. Not always, but mostly the same things. Any final questions? Okay, hopefully you guys got some of that content. On Wednesday, we are going to write if statements and write switch statements. And then once again, I'll probably run out of time and do another example video. I like having 2 lectures a week live, but 2 lectures, man, it just always just doesn't seem like there's enough time. Okay. Any final questions? Okay, I will jump over to office hours and I'll see you guys on Wednesday.